Hi guys. Today's video is about why nothing can travel faster than the speed of light. The reason is simple, because everything is moving at the speed of light. Whatever I said might sound ridiculous, but I will explain it in this video. We know light travels at a speed of 300,000 kilometers per second or 186,000 miles per second. Light has some special property that other objects in the universe don't have. It is massless, quite ironic since most of the things in the universe have mass, but light doesn't. So, how mass affects the speed? There is this relativistic energy equation from special relativity, which tells how much energy a body has, whether it is moving or stationary. E equals mc squared by root over 1 minus v by c whole squared. C is the speed of light. V is the speed of the object moving through space. According to this equation, when we substitute v equal to c, E becomes infinite. Only way to avoid infinity is to make m equals 0, so that we can get an indeterminate form. So how do we know how much energy is carried by the light? Thanks to quantum mechanics, there is an equation for it. E equals h times mu. H is Planck's constant, and mu is the frequency of light. In this case, we can get the idea that an object moving at the speed of light through space needs an infinite amount of energy. Or it can also be stated that a massless object always travels at the speed of light. So we can strongly say that anything with mass cannot move through space at the speed of light as it needs an infinite amount of energy. In this case, I think you should subscribe to my channel, since you watched this video this far. Pythagorean theorem. This is where stuff gets interesting. We all know what a Pythagorean theorem means. In a right-angled triangle, the sum of squares of two smaller sides is equal to the square of the larger side. We write the theorem in a differential form. ds squared is equal to dx squared plus dy squared. In 4D spacetime, we write it as ds squared equals alpha squared times dt squared plus dx squared plus dy squared plus dz squared. Alpha is used for dimensional purposes. Let's say an observer sees an event happening at t, x, y, z, in spacetime coordinates relative to him. So, the observer is basically at rest relative to that event, the distance in spacetime between him and that event known as spacetime interval, ds squared. But from the perspective of that event, it is at rest, meaning that ds squared equals beta squared times d tau squared. In special relativity, any two observers observing the same event will have the same spacetime interval. So, beta squared times d tau squared equals alpha squared times dt squared plus dx squared plus dy squared plus dz squared. This equation is known as metric. Now the question is, how do we find alpha and beta? Let's say that the event is at rest relative to the observer, then tau equals t. Then divide both sides with dt squared. The body is at rest, so dx squared by dt squared is equal to 0, similarly the others. We get the magnitude of beta equals magnitude of alpha. So the new metric equation is alpha squared times d tau squared is equal to alpha squared times dt squared plus dx squared plus dy squared plus dz squared. So, how do we find alpha? Simple, let's use the case of light. According to special relativity, light doesn't experience time. D tau equals 0, we get alpha caret 2 equals c squared. Now the equation modifies into ds squared equals minus c squared times dt squared plus dx squared plus dy squared plus dz squared. This is the flat spacetime metric, famously known as the Minkowski metric. So, we know that there is a limit to how fast a body can move through space, that is c. While moving at that speed, that body doesn't experience time. So we can also say that if a body is at rest, time runs fastest. Time begins to slow down as the body starts moving through space. As it approaches c, time stops. Put simply, velocity of any body is the distribution of speed of light. Conclusion. The property of spacetime makes every object in the universe travel at the speed of light through spacetime. Thanks for watching this video, guys. Hit the like, subscribe, and share this with your friends. See you in the next video.